All right, guys, are there questions on 1 through 6 or one of those in particular that y'all want to look at? Huh? Which one? Which one? Okay. Now, if we look at number 1, there's 3 different operations that are going on. We have the 2/3, the -2, and the 3. Now, the 2/3, since it's in front of the parentheses and is being multiplied, it's telling us that it's a vertical shrink. And we know it's a shrink because it is between 0 and 1. If it's greater than 1, it is a stretch. Now, if there was a negative in that spot, it would be a reflection across the x-axis. Now, the next thing we have is the -2 inside the parentheses, which is telling us that we're either moving it to the left or to the right. So yes. So it's right 2. And lastly, the +3 is telling us it's up 3. And that's it. So any other questions on number 1? So if we look at number 5, we have the negative outside the parentheses, the +3 and the -1. Well, the negative outside the parentheses tells us it's a yes. X-axis. The +3 is going to be left 3, because it's the opposite of what we'd think when it's inside the parentheses, and down 1. And that's it. Yes. Any other questions on these here? Right, where we're not actually subtracting something, because the negative in front of that parentheses, we're not actually subtracting from something, it's just a negative. Or if there's a negative in front of x inside the parentheses, it's across the y. So for 6, we have the 4 and -14, yes? So the 4 is a Yep. Yeah, with the -14 telling us that we're subtracting 14. So any questions on 1 through 6? So let's look at 7 and 8 first. 7 and 8 are both in vertex form. Now it's already written in the back of the review sheet for y'all, a times x minus h squared plus k, where the vertex is the point hk, and the axis of symmetry is the point x is equal to h. And we could look at either one of these. Well, for the number 7, the vertex, 5, because our h and k is the opposite of what we think. And the axis of symmetry is x is equal to h. X is equal to 1. Now for number 8, the vertex is our h comma k still. This one's going to be -1, 2, because inside the parentheses we have +1. And now the vertex, not the vertex, the axis of symmetry, we already have the vertex. Axis of symmetry, x is equal to -1. Any questions on any of this here? Now 9 and 10, it's in standard form. So we're looking at our y is equal to ax squared plus bx plus c. And our vertex is the point negative b over 2a, comma, f of negative b over 2a. And the axis of symmetry, x is equal to negative b over 2a. And again, I included these in the back of that sheet, back of the review sheet for y'all here. Now, do we want to look at 9 or 10? Okay. So the really thing we need to actually calculate is the negative b over 2a. Negative b over 2a. Well, what's the value of b? And the value of a is 6. And again, at this point, you can plug it in the calculator. Negative 4 over 2 times 1/3. So what that tells us that the vertex is the point 1/3, comma, blank. The axis of symmetry is x is equal to 1/3, because our negative b over 2a, those are the same for both of those there. Questions on this so far? Now we need to find f of negative b over 2a. Really, that's all that's saying is we take the 1/3 and plug it back in. So 6 times 1/3 squared, minus 4 times 1/3 plus 5. We're just plugging it in. And we can plug this into a calculator. 6 parentheses alpha y equals enter 1 over 3 squared minus 4 times 1/3 plus 5. 13 over 3. Yeah, I would leave it as 13 over 3. That works just fine. Any other questions on 9 or 10? Because 10 is going to work out the exact same way. Any other questions on 9 or 10? Let's look at 11 through 16. 11 through 16. And for these here, we'll add the vertex. We'll look for the vertex too. But the nice thing is about the vertex is the same for all of these here. 0, 0. Because we never talked about any of them that were away from the vertex. So no matter which one we do, the vertex for all these is. Which one do we want to look at first on 11 through 16? 11. Well, one thing I know is the vertex is. And again, I'm including that because it should be easy points, especially for this here. Now this one here, we have y equals 1/32 times x squared. Well, which one's being squared? The x, yes? So we can look back at the general form, which will tell us that the focus is 0, comma, p. The directrix is y is equal to negative p, and our axis of symmetry is x is equal to 0. Yes. And really all of this here so far is not from doing any calculations, it's just general form. Because whenever x is squared, this is the form that we have. Now we just need to find p. Well, is the equation in the correct form? Yes, because the y, the term without a variable, or the variable without an exponent, is by itself. And we're really matching it with y is equal to 1 over 4p times x squared. And our 1 over 4p will match up with our 1 over 32. Because that's where the p is located. If we plugged it in to 1 over 4p, we would get 1 over 32. So to find it, well, we can set 1 over 32 equal to 1 over 4p. Then our first step is to multiply both sides by 4p. Those will cancel. 1. Now we can do 4 times 1 over 32 to get it to simplify, especially in the calculator. And it'll tell us that we have p over 8. Questions on this so far? Now what can we do next? We can multiply both sides by 8 because these would cancel, telling us p is equal to. Now the focus is 0, comma p, so it's 0, comma 8. The directrix y is equal to negative p, so y is equal to negative. And that's it. But really, even without getting into the correct form, we should get most of it just from matching it up correctly. All of them are 0, 0, because we're not moving it away from the vertex. Because for any of these here, the vertex is understood to be 0, 0. Yeah. That's from the form. P, because the directrix for this form here is y equals negative p. And again, all of those, the general forms are included on the back. If you want to add that the vertex is 0, 0, you can. Because we did not talk about any of the ones where the vertex was away from 0, 0. Yes. I'm going to erase all this here. Now, which one's squared? Why? Now, I can look in the back, or y'all can look at the back of the different forms. Well, the vertex is the point 0, 0, because we didn't talk about any that were away from the vertex. The focus for this here is p, comma 0. The directrix is x is equal to negative p. The axis of symmetry is y is equal to 0. Have we done any calculations yet? No. And again, I would reference back to that back page whenever you're working on these to see which one does it match up to, which one does it connect to. Because, I mean, if each one of these parts was worth a point, we've got 2 points for the vertex. You got a third point for having half the focus. You got 1 more point for having half the directrix, having the x side, and then you got another 2 points for the axis of symmetry. 1, 2, 3, 4, 5, 6. And we're only missing 2 points. So these here are kind of nice. They're big, heavy problems, numbers worth. I mean, pretty much all of them, yeah. It's given to you. The only thing we need to find is p. Well, that's the general form is x is equal to 1 over 4p times y squared. And 1 over 4p is matching up to the negative 4. So we can set it equal to it. So 1 over 4p is equal to negative 4. What do we do first? We're going to multiply both sides by 4p. These here will, well, that won't. A little too used to having 4p on the other side. 1 is equal to negative 16p. Then we would divide both sides by negative 16, telling us p is equal to negative 1/16. It is very tempting to want to say, especially with a lot of the ones we did in the homework and practice, that just set the bottom of that fraction equal to 4p and solve. But this one here, did it have a bottom of the fraction? No. So we actually have to go through this process to find it.
So is everything going to be 4?
P? Mm-hmm. Because this 1 over 4p is from the general form. So a lot of the ones we did in class or in the homework, it was 1 over 8 was in that spot, or 1 over 2. And those do work out that we could have just set the bottom of the fraction. So 2, so 1 over 2, 2 equals 4p, and solve from there. But here, it's negative 4. I've got to set the whole thing equal to it. Now, we get negative 1/16 for our focus, because negative 1/16, comma 0, p, comma 0. And the directrix is x equals negative p. Well, the value of p is already negative, so it's going to become what? Positive 1/16. Well, we have to, in solving, we have to multiply by 4p first. It's going to be better to just do this process here to find it. Any other questions on 11 or 12? Questions on 13 through 16? We just need to get everything on the same side. But one of the things we do notice is that the y is being squared. So the vertex is understood to be 0, 0. Our focus is going to be p, comma 0. Our directrix, negative p. And our axis of symmetry is y equals 0. Yeah, so directrix x equals negative p, axis of symmetry y equals 0. We're matched it up to the general form, because the general form is either x squared or, which one do we have? What's the information that's given to us for it? Is this here? We're just leaving out the p. Now we do need to get this so that the x is by itself, so we can add 3x to both sides. Minus that negative 4y squared is equal to 3x. Then we can divide both sides by 3, telling us x is equal to negative 4/3 y squared. Because again, we needed to get it into this form so that we can find p, so we can find the value of p. And at this point here, we're saying that negative 4/3 is equal to our 1 over 4p, because that's what's going in place of the 1 over 4p is the negative 4/3. And now at this point here, we're going to multiply both sides by 4p. These would simplify, telling us that this is equal to 1. Over here, we're going to have negative 16p over 3. Now at this point here, we can multiply both sides by negative 3/16, or we can divide both sides by negative 16/3. Either one works. And if we multiply by negative 3/16 or divide both sides by negative 16/3, we get that p is negative 3/16. And we can plug it back in. And we get this here, and it should match up to the answer keys. Any questions on any of this here? Any other questions on these 4 here? Questions, or one of 15 through 19 that you all want to look at in particular? 15, 16, 17, 18, or 19. One of those in particular that y'all want to look at. Okay, we can look at 15. Now 15, the focus is a value comma 0 or p comma 0. We're trying to find the equation. The direct x is equal to negative p. Both of these are kind of a giveaway to which equation we're looking at. Now, which one of the general forms has p comma 0 for the focus or x equals negative p? Which one would it be? Is it x equals or y equals? 1 over 4p y squared. And I mean, even I can look back at the previous one here. X equals matches up for this here. So we have this information. And again, you don't have to memorize this. You have it written down there in the note sheet or in the review sheet. I would just have that open and looking to see what does it match up to. And we get this here. Now, what's the value of p? Positive p is 1/4. Negative p is negative 1/4. So the value of p is 1/4. So we're saying x is equal to 1 over 4 times 1/4 y squared. Well, 4 times 1/4 is 1 over 1 is just, so x equals y squared. And that's it. For these here, we just need to find the value of p, plug it in, and simplify, and we're done. That's all we have to do for this here. Any other questions on this one here? Questions on 16, 17, 18, or 19? One of those in particular that y'all want to look at. Yeah. So vertex of 0, 0, does that tell me anything? No, because both forms have a vertex of 0, 0. But it did tell me the directrix is what? X is equal to negative 2/3. Well, x equals negative p. Which equation has that? I'm just writing the general form. X is equal to 1 over 4p y squared. Because again, I would be looking back at those general forms and matching it up. Now the value of p, the negative p is negative 2/3. So p is positive 2/3. So we have x is equal to 1 over 4 times 2/3 times y squared. And again, I would type that into the calculator. I'd do 1 over 4 times 2/3 in the calculator and hit enter. I mean, we could do it by hand, but the calculator will simplify all the steps and do it in one easy motion. And I believe it's going to give us 3/8. We get the same thing. Any questions on this here? Any questions on 18 or 19? Because again, with all these here, we're just matching it up to the general forms and then plugging the information in, finding p and plugging it in, and that's it. Any other questions on these here? Questions on 20 through 24. 21. 21. So we're given 2 points and it passes through a third. Well, negative 14, 0 and 2, 0 are both x-intercepts. We know they're x-intercepts because the y value is. So what we're looking at, exactly, a times x minus p times x minus q. We're looking at it in this form. And really it's telling us that p and q are negative 14 and 2. And this here is just asking for the equation. I'm not trying to find any information from it. So the first thing I'll do is just plug this in. X minus 14 times x minus 2. Well, the minus 14 is just going to become plus 14, positive 14. Well, if you can at least get this far, you have 2/3 of the answer. Because the only thing we're missing is A. We're going to plug this in to get it. We'll plug negative 72 in for Y is equal to A times negative 10 plus 14 times negative 10 minus 2. At this point, we can simplify. Negative 10 plus 14 is 4. Negative 10 minus 2 is negative 12. 4 times negative 12 is negative 48A. And last but not least, we can divide by and I believe there should be 3/2. Because 24 can go into 72 3 times and 48 2 times. Now, this is not the final answer. The final answer is y is equal to 3/2 times x plus 14 times x minus 2. You have to have it in terms of y and x. Now, I just remembered this, and it's nothing big or hugely important. On the first one, where we're talking about describing the transformation, I'm not saying anybody in here, because I think everybody in here is fine. For the vertical stretch or shrink, really stretch and shrink, make sure you clearly write stretch or shrink. And again, because the only reason I'm saying that is if it looks like you wrote stretch for one that's shrink, I'm going to count it off. If it looks like it's shrink when it should be stretch, I'm going to count it off. Does that make sense? So at least make sure it's visible enough that most people who read it can understand stretch or shrink or can distinguish between the two. And for axis of symmetry, you're going to have x equals or y equals depending on what it is. You're going to need that. You can't just put the number. Questions on any of this here? Do we want to look at 20 or 22? One in vertex form. Do we want to look at 22 or 20? Either one doesn't matter. Because if we look at this one here, we're given a vertex and a point. So we're going to use vertex form. And the vertex is the point, h, comma, k. So what that's telling us is that y is equal to a times x minus h. Well, h is 2 squared plus 4. So the first thing we want to do on this here is plug in the values of h and k. So we're plugging 6 in for y and 0 in for x. Now we're just solving for a. Well, 0 minus 2 is negative 2, so 6 is equal to 0 times a times negative 2 squared plus 4. Well, negative 2 squared is 4, so we have 4a plus 4. Yes. Because we can't combine 4a and 4, so we'll need to subtract it. And 6 minus 4 is 2 is equal to 4a. Yes, divide both sides by 4, telling us a is 1/2. And plug it back in. 1/2 x minus 2 squared plus all real numbers. X is the input. Because we're defining an equation, not a given point. So x is any value. X is just defined as the input. We're only specifically looking for a value when we denote it as x1, x2, x3. We're asking for a value. Any other questions on this here? Do we feel comfortable with 20 through 24 with these here? And these here are the last ones, A through D, yes? I threw these in because I realized after I ran a copy of the review sheet off, I didn't include these. So I threw them in. So we're looking for the x-intercept vertex and axis of symmetry. And well, these are in standard form, not standard form, intercept form. Y is equal to A times x minus P times x minus Q. Where the x-intercepts are P comma 0 and Q comma 0. Our vertex is the point P plus Q over 2 comma F of P plus Q over 2. And the axis of symmetry is x is equal to P plus Q over 2. And we have this information here. Questions on, so we want to look at D. So D here. Edit. So we have this here. So what's P and Q? P is 9/20ths and Q is 11/40ths, or vice versa. So the easiest one to get first is our intercepts, which is going to be 9/20 comma 0 and 11 over, well, negative 11/40 comma 0. Because since it's plus, it comes out as negative. It's negative, it comes out as positive. Questions on this so far? Now the next thing defined is the vertex, which is our P plus Q over 2. Well, I'm going to write it over here to the side. Y'all can write it below it or somewhere else. Well, so P, so we have 9/20 plus negative 11/40 over 2. We can type this into the calculator to get our answer. 9/20 plus negative 11/40 over 2. And I believe we get 7/80. And I think that's what the answer key agrees with. 7/80. What's also nice is that the axis of symmetry, x is equal to P plus Q over 2. So it's 7/80. Those will be the same. Hopefully you've noticed by now that the vertex says value, one of the two values does match up with the axis of symmetry. Now we need to find the y value. Plug it in. So we have 10 times 7/80 minus 9/20 times 7/80 plus 11/40. We can type that into the calculator. I believe we get a nice negative 841 over 640. I think that's what the answer key says, yes? Because it should be on the back of that page that you're on. So I mean directly on the back of that page. 841 over 640, yep. Now, I will say this, the ones like this on the test and most of the ones on the test, I did make it so that the calculators will give it to you in fractional form. So if it gives it to you as a decimal, you can convert it back to a fraction. All of them will be, the calculators will be able to put them as a fraction. It won't just throw out a decimal number and not convert back over. But that's it. Questions on any of this here?